I want to show at Miramont how to do an alternate ductwork on the side. This unit is being changed out. It's lasted 23 years, and that's long for a MagicPak. And the key was good return air. They used the original large ductwork on the bottom, and then they went 6x30 on the side with a large hole there rather than hooking a small flex to the skinny hole. And with good airflow, it keeps pressure down on your coil and makes it last long. So in this job, I'm going to show start to finish upsizing from a 2-ton to a 2.5 ton for the top floor, and then how to do the ductwork on the side. And I'm also going to insulate it, because notice the brick there, they would have been losing quite a bit of heat through the brick wall with the air rushing against it. So the first thing to do is start tearing out the ductwork so I can use the hydraulic table. I'm going to use flex and sheet metal on this job, but they used duct board and it lasted 23 years. I'm going to save that end cap for the flex duct. So here's a problem I found. They didn't bother to mastic the supply air. So it's got major air leaks on the supply, and duct tape does not work. So if they would have used mastic up here, it would have been no problem. Ductwork is out. The room is clean. Disconnected on the top. I just got to remove the electrical. I wanted to also show this was wired to high speed, the black wire for the fan. That also was the key to making this thing last a long time. But the drain was cracked. You can see the little crack there. These drains crack super easy. You got to be super fragile with them. It's a good idea to put some safety wire nuts on there while you're working so you don't bump the breaker on. You're just gonna shock yourself. Here's the hydraulic table, the motorcycle jack, and I've gutted the heavy stuff on the unit. I'm ready to start dropping it, and then I'm gonna strip it down right here on the deck. The coil got stopped up. I'm surprised we're on the top floor. This one has the aluminum grill on it already, so I don't need to upgrade the grill. But we're going from the 43 inch to the 56 inch. So the unit's going to be hanging over on the top and the bottom. And it's going to go flush against the wall. So I need to make this the same as my install document, which I made this just so I don't have to remember what to do. And it's a step-by-step. I show with the old grill. But the main thing is you want to have your air separator right there so your condenser air goes out of the building and not back into the condenser coil. What I'm going to do is I'm going to cut this back to the wall on the top and the bottom. I'm going to add more Capcons into the concrete blocks on both sides, give it more strength. So I mark where the wall is, and then I mark 18.5 inches up. And that's where our separator is going to go. And notice that it's lower than the split. So you don't want to just have a straight piece of metal, otherwise all the rain that comes in is just going to go right down the wall and make a mess. So the separator is going to go down and up and have a gutter in it. Cut the bottom flush, cut the top flush. Now I bent this side over because I want this unit to be flush on the right, and I do want to get some screws on the left. I want to have the maximum size for the ductwork here. So I put a bunch of Tapcons and bent the metal, make my ductwork as big as possible. Make sure you got slope for your drain. When the rain comes in, it needs to run out. Just put some little metal spacers under there. So you can see here with the ductwork, we're going 6 inches up on the unit, and it's almost right to the duct. So I'm just going to bring the duct straight down a few inches and put some flanges. And if you look here, I marked it so the ductwork is going to go from here to here. It's going to cover this electrical. So I'm just going to move the electrical to the side. Main power come in on the side, which is better for water anyway. And then you can see the ductwork here and here. Just got to blank off the top. And I'm going to have the 1-inch flange where I can go ahead, put a few screws in it, and then put silicone around it. Got to break this off here. Now I'm going to make the air separator. I need a 12 by 30 piece, and then 8 inches for the large part, and then it shows all my folds. I had to use Tapcons on this side, just right up on the cement. So now you want to make sure you got a drain. It's not going to clog, and I just whack it. So I'm going to alter this one on this video. I'm going to drop down 2 more inches because I drew the fan right there, and it's just not going to squeeze. If that fan's ever got to get pulled, it's not going to fit through that hole. Plus the evaporator goes way up high. I'm going to go down 2 more inches. So to get airflow on the condenser coil, I'm going to have to knock some of this brick out on the bottom. Caulking up for leaks, but leaving the drain open, and the gutters are caulked as I screwed them in. Then you want to make sure caulk up along the front so you don't get a rattling grill, just like so. Here's the part where you see if your ductwork's going to make it. So I don't have 6 inches. Realistically, with the insulation, I'm going to have 5.5 inches. And it's 400 CFM per ton, so I need 1,000 CFM. And I'm using the 1/10 of an inch drop per 100 feet. So the ductulator is adjusted for 1,000. That would be a 14-inch smooth round or a 16-inch flex. This flex has a drop. So I am going to use a short piece of flex that goes straight across the bottom. Now most of the units out here would be a 2-ton, which would be 800 CFM, 5.5 by 28, or if you got 6-inch, 6-inch by 24, and that's kind of what they had. Well, yeah, closer to 6, but they didn't insulate the wall. So I'm going to open up this brick right here. It's called a dry diamond blade. Real easy. Now this is just for the 2.5 ton. It's like 1.5 hours to knock that brick out. 2-ton you don't need it because you're only going down 6-inch. We went down 8-inch, so I went ahead and just made better airflow. So right now I'm putting pins and I'm securing them with Tapcons, and this will hold the insulation along with silicone on the wall too. Duct liner also helps with sound, and then I narrowed it where I got some wind gonna hit the duct liner. So now let's go ahead and insulate the wall, and then we're ready to set this unit. I used an entire tube of silicone, put it all over. Now we're putting the pins, and then I'm going to cut these off. Set it up on the table first, then I used the bucket to get it under get the motorcycle jack under there. Now raising it up, and the unit's not going anywhere. We're going to get it up into position, and then I want to see the divider right where it needs to be. It's going to overlap 1 inch. So you can see I pre-notched for my rails, and then this one's actually going to go in there a little bit. So, and we're flat against the wall and almost to my divider. Right side is secured. Left side, I was actually able to cut the part of that frame for the opening. And then the key to putting the screws there is the 1 inch 5/16 screws. Let's have an angle tool. Something important before screwing the other side is check the diagonals, because it's real easy to use the lift table to adjust it to make it square so the panel fits. So I'm sealed at the top, sealed on the sides, sealed on that side, top back there. Now I need to make the return, and I don't want to just put this on the 5.5 inch. I want to bring it back a little bit, because with airflow, if it looks like it has good airflow, it will. And if it looks like it's a bottleneck, it's bad airflow. These Tapcon screws are nice. They're almost as fast as sheet metal screws, but you can only screw them in once. When you back them out, they do strip. I use silicone for the adhesive. Works good. And the pins are nice for lining it up, and then it goes right down. Ductwork's looking good. All the way up there, so now let's close it off. Little piece here. Go ahead and line it. The last piece of the puzzle goes right there. I put a couple dabs of silicone so the air divider doesn't vibrate. And running the drain now, bending some PVC with heat. Now the most important part of the job is checking the airflow. And that's on the return right here. And I use this meter. I put in the area, and 0.85 is the factor for these grills. And so my first check, I need 1,000 CFM, and I'm getting 968. So I'm gonna bump the fan up 1 speed and then measure again. While I'm bumping the fan speed up, let me show you how you check the Freon level on these units. What you do is you look on the evaporator. It needs to be 3/4 flooded. You can either use a thermal camera, or you can look at your sweat pattern. So we're sweating. This one feeds from the top and the bottom. The 2 tons just feed from the bottom, but we're dry just a little bit in the middle right here, and then we're wet everywhere else. So Freon level's good. So I actually had to go to the highest speed to get 1,000 CFM, 997. So I had to run the black wire. And for the auxiliary heat, I'm gonna run the second to the highest, which is the 960. It's a little bit lower on the airflow, but auxiliary heat's not gonna run very often, and the weather will be cooler anyway, which means the pressures will be lower when it runs the auxiliary heat, and that'll be fine. And actually a little bit lower is probably going to make the air a little warmer anyway. Here's a real quick on the wiring. We got our heat on our orange wire, and then we got our cooling / heat pump on black, which is the highest. And then I'll show you real quick here. So all 3 wires for heat. There's a W2. There's also a Y2 which isn't used, but they both go to Y. And then everything else is straightforward, common, reversing valve. And then write your airflow on your return. That way the next guy knows. If this was a 2-ton, it would be 800 CFM. If this was a 1.5 ton, it would be 600 CFM. This job also needed new breakers. They were literally burning up. Well, that's it for the complete install. Turned out real nice. I even went up in the attic and used a thermal camera, make sure the ducts are connected, and everything's sheet metal out here. So they're definitely all connected. Drain, since it's top floor. We got a little bit of slope here, so I can't dump water into the pan. These break real easy, so it's nice to have some rubber on there. It's not gonna break the drain pan. Seal the air leaks. Piece of electrical tape. That'll actually stay there 20 years. That's it. I hope you like watching the video. Thanks for watching.